Thanks a lot. I actually won't be talking about deforestation a lot. There was enough said before me. But first, let me introduce myself. So I'm Gennadii Donchyts. I'm cloud geographer at Google. So I'm working in Google Cloud. And we are a small global team working with primarily commercial customers, currently focusing on Earth Engine mainly, but also working across all geospatial stack of tools, services that Google provides. And that includes Earth Engine, BigQuery, Vertex AI, Google Maps, and other tools. But this talk gonna be about Earth Engine mainly, so it was mentioned multiple times today, so I will try to, before coffee break, to wake everyone up a little bit with some entertaining, showing different application of what actually Earth Engine is, and then also in showing few examples. And then after that, we'll talk a little bit more about how it integrates with other Google Cloud tools and also how commercial customers, so businesses, governments can actually use it currently. Because Earth Engine is actually not a new system or not new platform, so it exists for more than a decade at Google. But for many, many years, it was mainly targeted on researchers, on nonprofits, and it was used as a research tool, basically allowing to work with geospatial data. And it's perfectly fits in Google's mission to harmonize world's data, make it universal, accessible, useful. In this case, we are talking about geospatial data, in particular, large imagery data. So large-scale image data. If you have applications where you need to download and process petabytes of data sets from maybe hundreds of different providers, you will spend most of your time actually in this kind of, not in this green area where you would do data science. You will be downloading and harmonizing your data. So with Earth Engine, we try to flip this around and say, okay, let's allow data scientists to focus on data science, and let's Google do this once for all data sets. So currently, Earth Engine has about 90 plus petabytes of imagery data. These are multi-temporal data sets, so it's not just satellite imagery, it's different types of data sets, so elevation data, weather analysis data covering multiple decades, and also even the climate prediction data, so SIM6, for example, data set is available there. So you could use it in combination, combine all of this data set and derive really insights out of it. Next to this large archive of harmonized data sets, we also have large compute platform available. So this is dedicated cluster of compute nodes and APIs that can be used to actually process this data. So they are collocated, and then this system, when it was built, so it basically currently allows you using browser to access these data sets and start all types of very sophisticated pipelines sometimes, focusing primarily on image data. You could use vector data together with it, but what you see in time-lapse here, it's something I generated, I think I remember in the train, just writing some code to process, to generate time-lapse of deforestation, actually data in Brazil, using Landsat data covering probably 50 or 40 years, actually. And there is much more than deforestation, actually. So if you look at Earth, it changes rapidly, and we frequently don't see this type of changes in any geolocation data or intelligence data. So any place where you look on Earth, primarily it's driven by people, but there are also some mainly natural changes. You have kind of erosion of coasts, rivers. In this case, you see here maybe growing of agricultural areas somewhere in deserts, growing cities, and disappearing forest, appearing agriculture, and so on. So this, of course, impacts our planet, and just making time lapses won't help to actually impact decisions. You have to derive value out of this data, and I believe that we just scratched the surface, even after working a lot with these data sets. So I did, during my PhD, I was using this tool a lot daily, and I still feel that we did not uncover everything, all information available there. So it's a challenge probably for some AI application. If you look at some examples of applications, so deforestation, anything, or forest fires, for example, so any disaster type of events, It's something actually what if you use Google Maps, you're actually using this data in vector format. So you have a crisis response team who maps forest fires and shows it on Google Maps. But in fact, in background, there is, like especially for US area, there is satellites observing Earth, geostationary satellites every 10 minutes. And there is a pipeline running at Google processing this data, turning into vector format, and updating this forest fire maps. So it's one small, tiny example, but there are literally thousands of different examples out there which are using Earth Engine. And so here's example looking at floods, looking at some climate analysis models, tools, observing vegetation. So here's a time lapse of NDVI from MODIS, so medium resolution satellite, but also you can zoom in now in like 10-meter resolution. So thanks to data from NASA and ESA in particular, so from Copernicus, we have weekly 10-meter resolution data covering whole Earth. So there's a really huge amount of application you could do with it. And looking at agriculture, this is also very fast growing area. So you want to optimize how we're growing crops. With growing populations, you want to do it more efficiently in sustainable way. So this is a tool actually which can provide insights and companies building solutions on top of it. This one is more recent development, so looking at construction areas. So you can actually quantify with this type of data using optical imagery or radar imagery, detect where construction is happening, when did it start, when did it stop, and create maps of this newly constructed area. So there's really, it's huge. I think I can just talk for an hour, maybe just naming different applications. This one is actually one of research examples done at University College London here. There's one researcher who was published in Economist last year, so mapping the devastating impact of Russian war in Ukraine and looking at every building here across like 2,000 kilometer zone and then detecting what fraction of cities, of buildings was destroyed in this front line. So it's really, for many applications, accountability, also the humanitarian and other types of applications, this is a right tool to use. I have to accelerate a little bit. I think I will run a few minutes over time, but that should be okay. So here, if you're looking, you will get your coffee a little bit later. So if you're looking at how you would use Earth Engine to develop this type of application, we're talking about image data, but it's really multi-temporal or just stacks of images that you can define pipeline where you would process a lot of images at scale. And then it could be terabytes, it could be petabytes, but literally it's when you develop with Earth Engine, you're creating this kind of the processing pipeline. So it's not just pictures, you have to write code in either JavaScript or Python. So it's really at the low level system targets data scientists who have to write this code. And then once they write code, they can test it, visualize it in this type of web-based environment, or develop Python scripts to do it. It has quite steep learning curve, and then that's just to show you like how you normally would be doing this. So here I have very small demo looking at London, and so what I wanted to look here, how cool London is. So, and literally how cool you have areas. So these areas are cool, these are not so cool. And this is data representing temperature. So land surface temperature, which you can also basically at every few weeks, you get image from Landsat. And you could also monitor this temperature data. But of course, it's not, again, not just visualizing this. You could also just calculate trends in temperature in different locations. So you see here, its temperature is decreasing, increasing. This is just one tiny example. If you zoom in a little bit more at the area where we are now, so we are somewhere here, and I've just pulled here data from Sentinel-2 imagery and just created time lapse of least cloudy images. There are many cloudy images, probably 70% of images are cloudy, but these are least cloudy. And we can see here quite many like what we see in this signal, so just even visually observing this data, you see something happening in Hyde Park. There is some constructed building occurred, we can observe there. Some boats, we cannot see swans, unfortunately, this scale, but we see droughts. So during summer, we see shadows. So it's really many effects you could find in this data. And if you look at let's say, processing this data to get some insights, you would have to do like signal processing. In this case, I'm showing 3 months or 6 months averaged this data as a time lapse. And here the same, but with a window 1 year size. So you get like seasonal effects removed in the data. And then in this time lapse, you could start observing long-term kind of changes. So area where construction occurred, or maybe some buildings were demolished. So this is just some examples of how Earth Engine can be used. Another, done with examples, so maybe one important aspect to mention is where does Earth Engine stand currently in Google Cloud? So Earth Engine, so it was about 2 years ago, we actually integrated it in Google Cloud. And what it means is before that, it was used as standalone, more or less system. Currently, we're working hard also to make it interoperable with other tools. It became also available as one of Google Cloud services, together with hundreds of more than 100 other services. You actually can just start using Earth Engine and subscribe to license. So for businesses, governments, you would need a license, but it's also something we improve in this interoperability constantly. And we started also specialized Earth Engine partner program. So Carto is one of our also preferred partners, so providing geospatial intelligence. And we have many, many partners. Some of these companies are very specialized remote sensing experts. Some are, we have like Deloitte, Accenture, who can develop like solutions at scale. And so they can really help you to get started with Earth Engine if you don't want to commit into learning. But also we try to integrate Earth Engine with other tools. Like, and important, of course, to mention BigQuery and Vertex AI. BigQuery, again, I won't be mentioning. This is, you saw a presentation of Javier, and there is a lot to talk about how you can derive data from Earth Engine to BigQuery. A few words about Vertex AI before the break. So one thing to mention is that what we added as part of the integration with other Google Cloud services, we added a bridge or connector between Earth Engine and Vertex AI, which basically allows you in almost like one line of code in Earth Engine, you could talk to models hosted in Vertex AI, which could be any of not just, let's say, Google models or your own like simple algorithms, but it can be any advanced PyTorch or whatever third-party models hosted in Vertex AI, and then you could use them to do all kinds of inference. And this really complements default machine learning algorithms available in Earth Engine to do all kind of crazy stuff. Some of the model development we are doing internally. So here in this time lapses, you see one of, it's a slide from one of our research teams developing foundational model trained on different like multi-model data coming from remote sensing. So it's optical and radar imagery to do things which we cannot do with simple land use classification maps. Like, for example, you can query, where do I have golf courses? This is not something what you could do with just simple land use spectral kind of analysis. So this is something, if you have interested in these applications, so please go to this link and just send a message. So we'll get in touch with our team. And some, I almost done, so one more applications of this kind of more advanced AI is that it's coming from another team. It was published as a public paper, is where we take in coarse resolution Sentinel-2 data, and we basically generate super resolved, so it's like zoom in and enhance type of applications. And you basically literally generate refined resolution of Sentinel-2 from 10 meter to maybe meter resolution, and you have then high frequency, kind of high resolution observation data. This one is, I'm based in Netherlands, so this picture is very appealing to me. This is example of models developed not by Google, developed by Meta. So we experimented with models developed by other companies and trying to integrate it with Google Cloud environment. And this is last slide to show that when you combine this with high resolution imagery data, you could literally run it with a few lines of code within Earth Engine, host your models, in this case developed by Meta, and do inference and get results back in Earth Engine, create this type of pipeline and run them at scale. So with this, I will finish my talk. Thank you for your attention, and sorry for taking 2 minutes over time.